Here we have the two vectors u vector and v vector, and we have to find their cross product, that is u cross v. So I'm going to use the determinants to find the cross product. So I put I, j, and k, and then down below that, that is in the second row, I should put the components of u vector, that is -2, -2, and -4. Now in the next row, that is in the third row, I put the components of v vector, that is 2 times, I'm sorry, it is 2, 2, and 3. So we have to evaluate this determinant. Let's do that. So first I put I vector multiplied with, we have to leave the row and column represented by the I vector. So we leave the first row and the first column, and then we will get only this determinant. We have to evaluate this determinant by doing the crossing like this. We take the product of this diagonal minus product of the other diagonal, that is the 2 times -4. So when we do that, we get -2 times 3 is -6, and then we put a negative, and 2 times -4 is -8. So we are done with this I component. And now let's do for j vector. So we have to put -j, and we have to leave out the row and the column represented by j vector, and find its determinant. So we will get this one when we leave this row, this column, and this row, we will get this as well as this. So basically we have to take the product of the diagonals, that is we have to take this diagonal, that is this -2 multiplied with this +3. This is one product of the diagonal, and then the another diagonal is this one. The elements are 2 and -4. So let's do that. So -2 times 3 is -6. We put negative, and then 2 times -4 is -8, and then we close it. Now for the last one, that is for the k vector, we have to leave the corresponding row and corresponding column. That is, we leave this column and we leave this row, and this means we'll be left with this 2 by 2 determinant. So we evaluate by taking the diagonal and subtracting the other diagonal. So the first diagonal product is 2 times -2, which is -4. We put a negative, and other diagonal product is 2 times -2, and this is also -4. So we then close this bracket. Let's evaluate this. So this equals I times of -6, and this is +8. So I put -6 plus 8. Then we have -j times, this is -6 plus 8. And finally k is -4 plus 4. Let's simplify. -6 plus 8 is 2. So 2 times I is, I write down this as 2i. And once again here also, this is -6 plus 8, which is 2. But here we have 2 times -j, which is -2j. And then +4 and -4, this becomes 0. So 0 times k vector is 0. So this gets cancelled. So basically this is the u cross v, that is a cross product of the two vectors, u vector and v vector, that is u cross v. Now let's determine the magnitude of this u cross v vector. So I write u cross v, we find its magnitude, and this equals, we have to take the square root of the sum of the squares of the components. So the I component is 2, so we have to take its square, plus the j component is -2, so we have to take its square. So this gives under the root of 2 square is 4, -2 square, it is also 4, and this gives root 8, and this can be written as root 4 times root 2. Root 4 is 2, so it is 2 root 2. So therefore we see that the magnitude of the u cross v is 2 root 2.